international repute. He has also number of patents on his name. He is also a he is also leading a team of lane detection for extreme weather conditions, where the team is developing algorithm using deep learning frameworks. Prior to joining Mercedes-Benz Research Development Group, he has completed his PhD from NIT Rourkela, Odisha, and he has published 3 ACI journals, 5 international conferences, and he has been awarded with the Best Researcher Award in the Department of Electronics and Communication at NIT Rourkela. With this, I welcome you, Dr. Panda, to this faculty development program. And mostly we have the CBSE school teachers. I hope my participants will enjoy with your expertise because as you have already given your time to us, to Meghalaya, NIT Meghalaya several times. And again, we are very thankful to you that you have given another time also to share your knowledge with us. Thank you, Dr. Panda.
Thank you, Professor Bunil. And yeah, so I think we can get started.
Yeah.
Professor Bunil has given a very nice introduction about me, so I think we can get started with it. Okay, so in today's presentation, what we are going to do is we are going to do a hands-on session. So for that, we will be using Python, and for installing Python, you can directly install the Python, and or you can take the help of Anaconda. Okay, so Anaconda is actually a distribution of software that comes with pre-installed libraries which you need. So along with Python, you will be getting some other libraries. So then the next question which comes is, so for writing codes for deep learning, so you need Keras or you need PyTorch. Okay, so one can use Keras or one can use PyTorch. Okay, and let me get started with the introduction to deep learning with PyTorch. So in today's session, I'll be using PyTorch. One can write the same code in Keras, or one can write the code in PyTorch. There are some other libraries which are available, but they are not that popular. There are two. One is Keras, backed by Google, and PyTorch, backed by Facebook. Okay, so you can use any one depending on your choice. But if you know PyTorch, it's presumed that you can also work with Keras, and if you work with Keras, then you can also work with PyTorch. Okay, as I said, that you can install Python in your Windows laptop, or if you have a Linux, you can install. So for that, you can directly install, or you can take the help of Anaconda. Okay, so Anaconda is a distribution. So you can do that, and then you can install, you can use Keras, or you can use the PyTorch. And if you want to use the GPU, okay, so GPU, if you want to take usage of GPU, then you need to install the CUDA. Okay, so depending on the GPU, the kind of GPU which you have, you need to install the specific CUDA. And once you have installed the specific CUDA, then you can go to the. So I'll just show you. Is my screen visible to you?
Yes, sir, visible.
Yes, sir.
Okay. So for example, this is the one. So if you want to install PyTorch, so you need to mention PyTorch stable. Then you need to select which is your operating system. So in my case, I'll be using Windows, and the package can be your Conda. It can be if you're using a pip, so it can be pip, and the language is Python. And here you have to select your CUDA. So CUDA is something depending on the GPU which you have in your machine. Okay, so you have to pay attention to it. So you need to find out from your device manager. You can just have a look what is the GPU which you have. If you do not have a GPU, then you will not be able to take help of the GPU. Okay, so you will not be able to. Then you don't need to install CUDA. So what you have to do is you have to just select none, and this is what you have to run. Okay, so once you run this, so PyTorch will be installed in your system, and what people generally do is they create environments. Okay, so what people do is they create environments. So for example, if you want to install PyTorch and if you want to install Keras, so people create a separate container. So you can create environments. So there are environments, how to create environments in Python. So you can create a environment in PyTorch, and if you can create an environment in Python for PyTorch or for Keras, and you can install this. So if you create a container, if you keep all your softwares in your container, so you are not going to conflict. Means so one software will not conflict with the other one. So that's the reason why people generally install everything in an environment, and depending on your application, so you can use your particular environment. So this is about PyTorch. Okay, so let's get started with deep learning. So before I start, let me get a feeling of what you have learned. Okay, so
Dr. Panda, sorry to interrupt. One information I wanted to share. Actually, this session is up to 4 p.m. You can, we have some question answer session also, because this is the request from the participants that they will have a specific timing for question answers, right? So better you can keep some time for question answers also in your session.
Okay, yeah. So maybe I would suggest as we are doing hands-on session with the PyTorch. So I would ask you if you have any doubt in between. You can always ask. Be free to ask questions. And if you do not have any question, then at the end also we can take questions. Okay.
Sir, can you zoom in your screen? The font is very.
Okay. Let me do that. Is it visible now?
Better.
Yes, sir. Thank you.
Yeah, visible.
Okay, so now it's 200%. So let's get started. So before I start, I want to know. I want to know about what you have learned. So let's get started. Can anyone tell where do you see deep learning? Means where do you use deep learning?
Uh, Sir, it is for computer vision or image processing.
Okay, so I meant, okay, so you are telling that you're using deep learning for classification purpose. Okay, so I meant that can you tell a gadget where you're using? So for example, in your case, it's a mobile phone. So something like that, if you can give us some examples.
Face recognition?
Yeah, face recognition. You are using face recognition in your mobile phone to unlock your phone or in your tablets. Okay, then
Yeah, sir. Can we use this one for the finger authentication, fingerprint authentication?
Yes, you can do. You can do.
I see.
Anything else?
In Alexa, we are using deep learning.
Yes, in Alexa we have deep learning. So that is based on your recurrent neural network. Yes.
Home security system, sir.
In home
Security system.
securities, so where do you see in home securities, where do you see the use of deep learning?
So if a frequent person is coming to your house,
Okay, so someone you want to classify someone who's known to you and someone who's a stranger. So okay, so yeah, so in this way deep learning can be used. So what you can do is you can have a two-class classification problem. So in a two-class classification problem, what you can do is you can make your family members and the others are your non-family members. Okay, yeah, that's a good example. Then anything else? Maybe let's make this as interactive session, and then we can
So,
go ahead.
so while surfing internet and if we are accessing any website, for example, if I'm using Facebook, so I will be shown the same set of advertisements, what I have been looking for, the products, what I have been looking for. Is it an
Okay.
example of deep learning by the Facebook?
So it is something like I would say in Netflix also. So for example, if you in Netflix or in Amazon Prime, if you watch a certain kind of movies, then then you may like those movies which others have liked it. For example, if you like one kind of particular movie, so which has some actor or actress in it, and then what they do is they just they make it as a group, and if some other person has seen that movie and he is belonging to your group, then that is also an example. Okay, so yeah, recommendation.
does Google Smart Reply use it?
Yes, Google's in Gmail, you have this smart replies from the last, I think, 3 to 5 years, which we are seeing. So what they do is they go over your Gmail, and depending on what the email is, so they will write a suitable reply to you, a suitable reply for you. Okay, so there are cool examples of deep learning. So as one said that we are using deep learning for classification purpose. So so deep learning can be used for logistic regression. So logistic regression is nothing but your image classification problem. The other can be your linear regression, where you have to, for example, if you have continuous values, and the best example is the house price prediction, or if you want to uh, tell that which one is outliers, or if you want to uh, plot a line over your data, so that is nothing but a regression problem. Okay, so as one said that in mobile phones we are using for computer vision, we are using it for image classification purpose. Then be it Alexa, be it Siri, or your OK Google, we are using. So basically what happens is it's a text to text, or it's a voice to voice. So there we are using RNN. So RNN is nothing but a one form of a neural network which is fed back. So you have a feedback, and nowadays we have this long short-term memory. So that is being used. Okay, and yeah, so let's get started with this. So maybe and one example which you guys left is the use of deep learning in self-driving cars. So self-driving cars is not a distant dream. in 1 year or 2 years, you will be seeing self-driving cars on the road. So there are different levels: level 0, level 1, level 2, level 3, level 4, and level 5. So level 5 is a distant dream, but level 3 is somewhat next year, and level 2 is currently running on the roads. And yeah, so self-driving cars is one best example where deep learning is being used. Okay, so what we will do is, in today's session, we will be seeing mostly about neural networks, and in tomorrow's session I'll be seeing more, means I'll be showing you more of CNN based. Okay, so today's session will be more on the neural network side. So we'll start with simple neuron, and then we'll go towards a multi-layer perceptron, and then so we will gradually move. Okay, so let's start with a simple neuron. Okay, so in
So
a
how to install the PyTorch? Can you just tell again?
Okay, so one thing is you need to have a laptop. Okay, so in your
Yeah.
laptop, you need to see in your device manager whether you have a GPU
Okay.
installed or not. Okay, so if you have a GPU installed, then you need to find the name of the GPU. Once you have got the GPU name, then you need
Okay.
to find out the actual CUDA version. Okay, CUDA is something which has been written to optimize all the TensorFlow operations in your deep learning. Okay,
Okay.
so that is something. If you have a GPU, then you need to install the CUDA. And for installing the CUDA, there are different versions of it. So it can be 9.2, 10.1, 10.2, 11. Or if you don't have a GPU, if you don't have
What
a
is
GPU,
GPU, sir? What
yes.
is GPU?
GPU is your general processing unit. So in your laptop or in your computer, you have two kinds of things. One is CPU and the other one is GPU. So what has happened over the years is that the gamers have been asking for the real kind of video gaming, and for that the GPU has been pushed to a larger extent. Okay, the GPU was used mainly for gaming purpose. If you want to have a real feeling of the game. Okay, so that is what is there with the GPU. So NVIDIA is a powerhouse. NVIDIA is a powerhouse in GPU. It's a means they make GPUs for the last 10 or 20 years, and that was meant only for the gaming purpose. Okay, but what has happened over the last 5 years? What we have seen is we have seen the growth of deep learning, and for deep learning, you have datas, and datas need to be you need to do a matrix operation, and for that GPUs are very good in it to handle all these things. And for that you need a CUDA library. So so your GPU, and then on top of that you have a CUDA library. So you need to find out which GPU you are using. Okay,
So can I ask a question?
I didn't get you.
Sir, I have a question. If I don't work with the Anaconda installed on my system, and if I work with the Google Colab, can I still deploy my models using the GPU and TPU that come already installed with the Google Colab?
Okay, so there are two things. One thing is if you are running a simple model, you don't need a GPU. You can use the GPU which is available to you in Google Colab. So Google Colab gives you free usage of GPU for certain duration. But if you want to train a bigger application, so for that you need to have a GPU, and for GPU, CUDA is a must. Okay, and then
Okay.
so did I answer your question?
Yeah. Thank you, sir.
Yeah, I just have one more question regarding so for example, I use a Rogue Zephyrus model that I have. and it's a very powerful machine. I've very recently just got it. I just needed to know if I want to actually train a larger data set, then do I need to install CUDA still with my Google Colab in case I'm still working on it
So
in
for
place of
that, so in Google Colab you don't have to worry. So in Google Colab, the best thing is it's been given by Google. So the best way is to use the Keras framework, which comes built in,
Okay.
and you can write your code. So you don't have to worry at all.
Thank you very much, sir.
Okay, so I think one madam asked about means how to install the CUDA and how to install the PyTorch. So did I answer your question?
Yes, sir. Thank you very much.
Yes,
Yeah.
sir.
Okay, yeah. So this is what. So you need to select your what PyTorch you're looking for, then your operating system, package, then language, and CUDA. And if you don't have a GPU, then you don't need to install the CUDA. So CUDA will be none, and you have to just simply select this. Okay. So let's get started. Okay, so this is a single neuron. Okay, and what are the inputs? So x1 is the input, x2 is the input, b is the bias, w1, w2 are the weights. Okay, and then what is happening is we are multiplying w1 with x, w2 with x, and then bias is multiplied with 1, and then you are summing it up, and then this is what you have got is h, and then you give it to a function. So basically this function can be you need to apply some nonlinear activation, and then you will be getting some output y. Okay, so let's get started. So with tensors, so in PyTorch, all your operations. For example, if you have studied about Python, in Python you have a NumPy library, and all your arrays, matrices will be NumPy. But if you want to use the PyTorch, so for that you need to convert the NumPy arrays to PyTorch. Okay. So let's get started. So what are tensors? So this one is a tensor of single dimension. This is a tensor. Basically, this is a matrix. This is a vector. Okay, this is a this is a vector. This is a matrices, and this is what the actual tensor is. A tensor of 3 dimension. You have height, you have width, and you have these channel. So basically, we will be using all these three in our applications. In our so this is your vector. Okay, so let me show you one. Is my screen visible to you?
Yes, sir.
Yes,
No.
sir.
Yes, sir.
Good.
Okay. Okay, so this one is a vector, this one is a matrices. So but basically we call this as a tensor of 2 dimension. Then this is a tensor of 3 dimension. Okay, and then so first thing is
Sorry to
yeah.
interrupt. The cursor color and the background color are same white. So when you point, sometimes when you go on the white base, we are not able to see the cursor. Probably the cursor color.
I'm not sure. How can I help you?
Okay. Under control panel mouse, you can change the cursor pattern.
Okay, let me check.
If it is possible. Otherwise, okay.
Excuse me, sir, one question. Is there any difference between arrays and tensors?
There is no difference. You can call it as you can call it as a scalar. You can call it as a vector. You can call it as a matrices. So it all depends on how do you want to see it. So let me share something with you first.
Yeah.
Okay. Is this presentation visible to you? I
No,
have a
sir.
PPT.
No.
I have a PPT in front of.
Okay, okay. It's not visible right now.
Okay. Okay. So let's get with this one. So this is a scalar. So you can call this uh, as a tensor as well. Okay. So there is no confusion. This is a scalar. Scalar have 0 dimension. So you can call this as a tensor of 0 dimension. Okay. Then if you want to measure the height of the person, weight of the person, and the age of the person. So height is in centimeter, weight is in kg, and the age. So this makes up a vector. So this is nothing but a tensor of one dimension. Okay. Then this one, if you take an image, okay, and if you take this image, if you assume this image to be a grayscale, okay, so this is nothing but you can call this as tensor of 2 dimension, okay, and this is what. So you have tensors of 0 dimension, 1 dimension, 2 dimension, and then 2 plus dimensions, okay.
Yeah, thank you so much, sir.
Okay, so let's okay, so first thing is you need to import torch. Once you have import the torch, then you need to define your weight, you need to define your input X, and B is your bias. Okay.
Sir, yeah, screen is not there.
So presentation is not visible right now.
Okay. Okay, now?
No, sir. Yeah, yes, sir.
Yes,
Okay.
sir.
Fine, sir, now.
So yeah, so the first thing is what you have to do is you have to import torch. Once you have import torch, then you need to import the numpy. So from your numpy, we are using it as np. Then you need to define your weight. You need to define your input X. You need to define your B bias. Okay, so W is equal to np dot array. So this is you have defined 1 comma 1. Then input is your X, np dot array. 1 comma 1, and then B is your bias. So this is a scalar. Okay, this is a vector, this is a vector, and this is a scalar. Okay, and then what you do is you do a dot product between your W and X, and then you add a bias. Okay, this is what you have got. And then you need to apply a activation function, and for that what we are doing here is we are using a sigmoid activation function. So if you want to define a sigmoid activation function, and if you recall the formula of sigmoid activation function is 1 by 1 plus exponential of over minus x. Okay, and then what we do is we need to generate some data. And if you want to generate in case of random numbers, you can set the random seed such that every time it will not generate different numbers. Every time it will be generating the same numbers. Okay, so this is what the idea is. If you set the manual seed to 7, you can set any number, so it will always be using the same seed for it for generating the random numbers. And this is a torch dot rand n, and this is 1 comma 5. Okay, this is a vector, again a vector, and you can just have a look. If you print your feature, So this is how it will look like. It's a 1 row 5 columns, so it's a 1 comma 5. Okay, and then weight is nothing but torch dot random. So you have taken this torch dot random. So what we are doing is we are from the torch library. They have a function random which can generate the random numbers, and this one torch dot random underscore like. So you're using the same dimension of this one. Okay, weights you have got it, and then bias is a scalar 1 comma 1. And then once that is done, let's go. Let's call the activation. So as I said, we are using the sigmoid activation function, and that is what is being returned here. Okay. Okay, so y is equal to activation, then torch dot sum. So instead of writing it terms of dot product, you can also do that. Instead of writing using the np dot, which we had used here, np dot, you can also write your own.
Hello, sir. Sorry to interrupt. I cannot connect anything. Like, what are we going to do actually in this program? You are showing us some commands, but I don't know what at the end what we are going to do. Are we creating some new artificial neural networks? What are we going to do at the end? Means all these. What is the output of this program?
Okay. So let
Yeah.
me. I think this is a hands-on session, and when I am doing a hands-on session, so I assume that you can go over the code and just have a feel of it. Okay, it's not possible for me that you type in and then I will be waiting for you. So it's not possible for me. So what I'm going to do is I'll just show you simple programs which you can go over, and I can share the code with you. That's what the idea is.
That I understood, sir. So at the end of this program, what are we making? Like, what is the output actually? What you're about to say, I could not connect. Like we started with PyTorch. PyTorch is a library. I understood. In that, arrays are there. That arrays are known as tensors. That also I understood. Now we are doing some programs using those tensors. Are we creating an artificial neural network using this program?
Yes, so it's a simple neuron which we'll be creating, and for that I'm just showing you how you can write in PyTorch.
Okay, sir. Thank you. Thank you.
Okay. Okay, so this one is activation. I do assume that you all have gone through Python. Okay, so I do assume that you all have gone through Python and you all have studied about neural network. This is a hands-on session, so I'll not be going into detail of Python or into details of neural networks. Okay, so this is a hands-on session. So I'll be just showing you simple programs, and then on top of that, will be gradually moving. So this is what the idea is. So this one is a simple neuron. First, what I did is I just showed you a simple neuron. It's an artificial neuron, and what are the inputs, what are the weights, and how do you sum those. Okay, and then you apply a activation function and you get some output. So and then we'll gradually be moving. Okay, so this is what the idea is. Okay, so let's get started. Okay, so this is so you can call the activation function, which is a sigmoid, and then you can just have a look at what is your print statement. With your print statement, what is the value? So this is what is the output which you have got. This is a tensor. Okay. And the same thing you can do with torch dot matrix multiply. Okay, the same thing can be done. with matrix multiply as well, and you can multiply your weights and the input feature, and then you can add the bias to it, and then you can apply a activation function. Okay, so let's get started and let's stack them up and let's see how we can give it. So this is a input layer, this is a hidden layer, and this is your output. Okay, and this is your weight matrices, weight metrics, and so this one is W11. So this is the input neuron which is being connected to the hidden neuron. So that's what W11 will look like. Then W21, W12 is same. Okay, so let's get started with this. So here, as I said, we need to generate the random numbers. So for that, I have given a particular seed. So particular seed is 7. Then feature is your torch.random. Here, my input is 3. Okay, so in this case, the input is 3, x1, x2, x3. So what I've done is it's a row 1, column 3, and then you have got the number of inputs. Then there are number of hidden neurons. So there are 2 number of hidden neurons, and then n output is 1. So I have defined my weight matrix W1 and W2, and B1 is your bias and bias 2. Okay, and then you can just
Sir, excuse me, just sorry to interrupt you, sir. Sir, is there any way to find out the number of hidden layers in our neural network?
I means on the number of how many hidden neurons.
Yeah, how many
Okay.
hidden layers are there in?
Okay, so I'll be coming to that part. Basically, this is a simple neuron example, and when we go to some complex problems, at that time, what will happen is you will be giving a input. So input can be your image or it can be any data, and then I'll be just showing you that if you have too many layers, too many hidden layers, so there will be chances of overfitting. Okay, so in order to overcome the problem of overfitting is a concept which I'll be covering in today's session. Okay, so nothing to be worried about. So there is a problem of overfitting. Overfitting is just like if you memorize. For example, if a student is knowing what kind of so for example, if a questions is known to a student, and if he by hearts, if he memorize it, and then if he goes to the actual exam, so what will happen is if he has memorized everything, all his questions and answers, and then if he goes to real life practical problem solving, at that time he will fail. So how can we overcome that problem? That is nothing but overfitting. So that is where we need to drop some neurons from our hidden neurons, so that we will be seeing. So there is no particular number of hidden neurons which you can do, but what you can do is you can just play with the hidden neurons. So if it's a simpler problem, then try to do with a less number of hidden neurons, and if it's a complex problem, then you need to add more and more hidden neurons. Okay, so did I answer your question?
Yeah, thank you, sir.
Okay, so in tomorrow's session we will be going over the CNN, and in CNN I'll be just showing you what the input layer and what the hidden layers will be learning. Okay, and then if you add more and more layers, so you will be learning more and more features. Okay, and then you can understand what is the importance of this hidden neurons. Okay. Okay, so let's get started. Okay, so this is what you have to do. Basically, if you want to have this is a 2-layer neuron. So this is a 2-layer neuron. You have a input layer, you have a hidden layer, and then you have output layer. And that's the reason why we have multiplied. We have 2 times we have applied a activation function, and here the activation function is nothing but a sigmoid activation function. Okay, So let's get to NumPy to torch. As I said that your data will be in NumPy, but your PyTorch accepts your data in Torch. Okay, so you need to convert the data types. So first thing is okay. So import NumPy as NP, then this is a random number generator. So this will be 4 number of neurons, four number of rows and 3 number of columns. So this is giving you a 4x3 matrix, and this is nothing but a NumPy array. And if you want to check, just type in type underscore a NumPy ND array. Okay, and then B is equal to torch dot from underscore NumPy array. So you can convert your NumPy arrays to torch data type by the use of this command, and this will give you the same value. You can just check, but the data type here is torch. Okay, and then you can convert back to NumPy as well. This is how you have to do. Okay, so so what we have seen till now. So I just showed you Python. Then I showed you about Python, how to install PyTorch, and then we went to artificial neuron, a single neuron. We saw that how you multiply input x with the weight matrix, and then you apply activation function. And then we saw a 2-layer neuron. Okay, and this is the 2-layer neuron. You have a input x and you have a hidden layer. And then one madam asked about what is the how should we select the number of hidden layers, means how many hidden layers you should have. So there is no particular answer to this. It all depends on what kind of problem you are trying to solve. If it's a simpler problem, then you don't need to add too many hidden layers. So that if that can be solved with 2 to 4 hidden layers, then then your problem is done. But if you're trying to solve a complex problem, then you need to add more and more hidden layers. And if you add more and more hidden layers, the chances of overfitting will be there, which we will be seeing in today's session. Okay, and yeah, that's it. And then we also saw that you have a NumPy array, and the NumPy array needs to be converted to torch data type before you give it to your model. And you can convert from NumPy to torch to NumPy. That's what we saw. Okay, any questions till now? If you have any questions, maybe we can take it up.
So the weights will normally not be random numbers, right? The weights would be, I mean, in real life, the weights would not be random, right?
It all depends. I'll be showing you. You need to start with random numbers. Okay, random numbers. Weights will always be random numbers.
Okay. So then, as part of learning, the weights would be adjusted.
Yes. So when you train your neural network with the number of epochs, as you train for more and more epochs, you will be adjusting the weights of your neural network. That is what we will be seeing. Okay, and in tomorrow's session, I'll be just showing you what happens is there was a ImageNet competition, and 2012 was the year when the AlexNet was showcased, and that is the year when people got to know the importance of deep learning. Means they realized that what deep learning can do. And if you see from the year 2012 to 2017, there are ImageNet winner competition models which are available in PyTorch. So what you can do is you can take their weights. Okay, you can take their weights and then you can adapt the last layer depending on your application, as we saw in one of the example which I in which one madam told about that about the home security. So there is a 2-class classification problem. So what we can do is we can take the ImageNet model, which is well known, from 2012 to 2017. We can take the ImageNet model and we'll just replace the last final layer, okay? And then we will be using it to train persons which are family members and non-family members. So this is a binary classification. So there we'll be taking the weights from the ImageNet models, and then we'll be just training the last layer or fine-tuning the last few layers. That's what we will be seeing in tomorrow's session. Okay, so we will be you can experiment with it. You can start with random values, or you can start with a you can assume it to be 0, and then you have to see how quickly you are reaching to a global minimum value. But generally what happens is people generally go for a random distribution. This is a Gaussian distribution, and the weights are initialized to a random distribution, and then they go for training. Okay, and the training can be for 10 epochs, 100 epochs, depending on your problem statement, on your application. Any more question? Okay. So let's go to one more example, and this one is neural networks in PyTorch. So what we saw in this one is we wrote our own artificial neuron. We multiplied input X with the weight, and then we applied a activation function, and then we tried to. So how PyTorch can help us? Let's just have a look. Okay, so PyTorch has some built-in APIs for this. Okay, so this one is a simple simple example, and in this case I'll be using the MNIST data set. So MNIST is your Modified National Institute of Standard and Technology. Okay, so and this is a very popular data set which is being used among the machine learning community or the deep learning community. If any data set which is favorite to them, so this is something which they use it. Okay, so let's use the MNIST data set for this example. Okay, neural networks with PyTorch. How PyTorch can help us? Let's have a look. First one is we will be using the matplotlib. Okay, so this command is meant only for your Jupyter notebook, and if you want to show your plots in the Jupyter notebook, then you can write this, and if you want to make the figure format look good, then you can use this command. Okay, and then we have this basic command, import numpy as np. Then we have the import torch. Okay, then import helper, import matplot, lib.pyplot as plt. So this is a matplotlib. So if you know about the MATLAB, so this is basically you can use the same plots which you have in your MATLAB. You can use the same for this. Okay. So this one is a handwritten character of 28 cross 28 pixels. Okay, and this is 0. This is 1, 2, 3, 4. So basically, this is a 10 class classification problem. Okay, and I'll be showing you with a neural network, and then this example can be taken up with CNN as well. How means what is the accuracy, what is the jump in accuracy that we can see with CNN as well. But in today's session, it's all about neural networks. So let's see. Okay, so what you can do is you can from Torch Vision, we need to import the data set, and we need to import the transform. So data set is MNIST data set comes pre-built with the Torch Vision library. So from Torch Vision, I need to import the data set, and this is nothing but a transform. So basically, what we are doing is we need to convert our this NumPy arrays to tensors. So that is what is being done, and then we can normalize the data set. So we will be seeing different types of normalize as well. So for the time being, just know that we need to normalize our data set, and then we can feed it to our model. Okay, so we need to download and load the training data, and for this we have this train set. Okay, and then we have the train loader. Basically, train set will download the MNIST data set. So download is true, train is true, okay, and transform. So basically, we will be using this transform. It will basically convert it to a tensor, and then it will normalize all the data. Okay, as I said, this one is a grayscale image. This is a 28 cross 28 grayscale image. So in a grayscale image, you have only one channel, okay? And the height and width of the image is 28. Height is 28 and width is 28, okay? And then once we have downloaded, then the data needs to be loaded, okay? So data needs to be loaded, and so for that we take the help of data loader. And the same is also there in Keras. So if you know PyTorch, you can use the same thing in Keras as well, but the name will be different, okay? So we'll be using the train set, and batch size is 64 and shuffle is true. Okay, so can anyone say about the batch size or about shuffle? Yeah, so if you have studied about neural networks, so maybe I do expect that you may have studied about the batch size and the shuffle. Anyone? Okay, so in my introductions part, I was explaining about PyTorch, and for PyTorch you need to have I was explaining about the CUDA, and for CUDA you need a GPU. So let me explain you. So your data will be there in your hard disk. Okay, so it will be there in your hard disk. So CPU is something which you will be using to fetch your data. Okay, once you have fetched the data, so CPU's job is done, and then you give it to your GPU. GPU is where you will be doing the forward propagation and the backward propagation. Okay, so that is where the batch size comes in. So depending on your size of the GPU, depending on how costly you have bought the GPU, so there is a restriction. So that means how much you have a model, which is lying model, means you have a neural net model or you have a CNN model. Okay, you have a neural network, so that sits in your GPU. And then along with that, from your CPU, in your computer, you have a CPU. So data from your hard disk, you have load the data, and the data set is loaded from CPU, from the hard disk by a CPU, and then that is being given to GPU. Okay, now the job of the GPU is to do the forward propagation and the backward propagation, but there is a limited amount of memory in GPU as well. Okay, so for that, we need to come up with what is the batch size which we should define. So if you have a bigger RAM GPU which is available to you, then you can increase the batch size. But if you have a less RAM size, then you need to decrease the batch size. Okay, did I? Is the batch size concept clear?
So as you said that when you're installing the PyTorch, you said that even if you don't have a CUDA, you're able to install or the GPU. Without that, the PyTorch is getting installed in your system. But how exactly it is?
Okay, so yeah, I'll be showing in this code. So if you don't have GPU, that means you don't have a CUDA, and so all your operations, all your tensor operations will be happening only in CPU. So you are not taking benefit. You are not taking benefit of GPU. So if GPU is not available, so you in terms of time, the inference time will be more. So it will take more time to train the weights of your neural network. So that's it. So if you have a GPU, then you have a CPU and a GPU. So CPU's job is to get the data from the hard disk and then give it to the GPU, and GPU will do all the tensor operation. And if you don't
So
have
that affects the output of the tensor. Am I correct?
It will not affect. Your neural network will be trained. So instead of training it in 1 hour, it will take 3 to 4 hours. That's what the difference will be.
Okay. The time constraint gets extended if you don't have a GPU.
Yeah. Yeah.
Okay. Thank you, sir.
Okay, and then there is a shuffle. In this case, if you see, shuffle is every time the model will be given random images. So, for example, it is just like in board exams. Okay, in board exams, what happens is there are set A, B, C, D. And set A, you will be having different patterns of questions, but the same questions. Set B will be getting the same questions, but the pattern will be different. C will be getting the same questions, but different pattern. Likewise, the same thing is here. Shuffle means uh, the model should not memorize. So after one data, the second data, third data, it should never memorize. So every time the data, the batch, or the images which it sees will always be random. So in this way, you are training your model for the real life examples. Okay. Did you get this shuffle? Shuffle is something. So while training, we always make sure we make sure that the data which the network sees should always be random. It should never be. For example, if you have 100 images, so 100 images, if you show it for 10 epochs, so every time 1, 2, 3, 4, 100 images will be shown, and what will happen is your model will by heart, so it will memorize. So it is just like a student who's appearing for the exam. It will just memorize the pattern 1, 2, 3. So if anything comes other than that, so the student may fail. The same thing is here. So instead of feeding the data 1, 2, 3, it should be random. Sometimes 10 will be first, sometimes 100 will be first. So likewise, you will be giving it to your model every time different random numbers, means different random data. Okay. So this is what once you download, this is how the messages will look like. So nothing to be worried. And if you want to see, you have the train loader, and if you want to iterate over the train loader, so you can have a look. This will give you images, and then there is a labels. Okay. And if you want to type the images, so this is a tensor, as I said, that here we have used a transform, and this transform is nothing but it's converting it into a tensor. Okay. And yeah, so that is what if you see here, then images.shape. So this is a 64 is your batch size. Okay, 1 is your grayscale image, 28 is your height, and 28 is your width. Okay, and then dot size, and if you want to just have a shape of your label, so as there are 64 images in a batch. Okay, and so 64 labels will be there. Any doubt here? And please don't get confused with this notation. Sometimes what happens is people do write 28, 28, 1. So 1 is for the grayscale. In PyTorch, what happens is they write the number of channels first. Okay, and this is the number of images in your batch. And as I said, so batch, the batch, you can play with batch. You can start with 2, 4, 8, 16 in a multiple of 2. You can go, and this is something 64. Then you have 1 as number of channel, then 28 is your image height, and 28 is your image width, and this dot size is for the labels. Okay, and if you want to see, you can squeeze it, and then if you want to display it, it's a gray. So this is how it will look like. Okay. Okay, so let's go. Let's define our activation function. So this is our activation function. So first, we will be writing our own neural network, and then I'll be using the PyTorch inbuilt APIs which are there for you. Okay, so in this case, weight 1 will be 784. First thing is input is an image. So input is a matrix, and the matrix, as in this case, it's a neuron, and then we need to give it to our model. And so it should be first flatten. That means you should, I'll just show you. Flatten means you are making it of one column. So 28 cross 28 will give you 784. Okay. Then 256 is your hidden neuron, and then this is your bias, and then W2 is your 256. And as we are trying to solve a 10 class classification problem, so 10 is here. B2 is your bias 2, and H is what we have got after the activation function. And this is how it will look like. Okay. So this is how this is your 6. And if you want, so if you see the class probability, generally what happens is at the output, instead of applying a activation function, we can go for a softmax. So softmax, what it will do is it will apply all the probabilities in 0 to 1. So you need to make it 0 to 1. So in this case, if you see, all are of equal probability, but if you want to give it some probability for the 6, then you need to make it a softmax. Okay, so that is what the softmax needs to be applied at your output. Okay. Then let's see, can we write the same thing in PyTorch? So PyTorch has a inbuilt this one nn.module. This is a class, so we are inheriting from .nn.module. This one is a constructor. Okay, and here we have defined. So this is your hidden. So first is 784 is our input, and 256 is our hidden. Okay, and then from 256 we are going to 10, and then we have the sigmoid which we'll be using, and then as I said, we need to use the softmax at the output just to get the probabilities in 0 to 1. Okay, and then if you see self.hidden x, so this will be called 784 256. Then you apply a sigmoid. So sigmoid will be applied 1 by 1 plus exponential over minus x. Then you have got the output. So output will be your 256 10, and then you have applied a softmax which will give you probabilities in terms of 0 to 1. Okay, and that is what and if you want to see the model, so this is a 2-layer neuron, and this is what is shown here. Okay, any question, any doubt if you have? So one can use sigmoid, one can use tan hyperbolic, but nowadays the popular activation function is ReLU, and ReLU is what because of which we are now able to train layers with 250, or sometimes we go more than 1000 layers. Okay, so it is all because of the ReLU. So ReLU is now more popular as compared to the other activation function. And if you use tan hyperbolic is being used in GAN where you want to generate images. So that is one thing. You can use tan hyperbolic, but ReLU is the most popular. But if you want to start with the basic, so we can go with the sigmoid, and we'll be seeing in our CNN examples that when we train for more and more number of layers, then what is the importance of ReLU? So what happens is we get this vanishing gradient problem. Okay, and that problem can be overcome with the help of ReLU. Yeah, I think someone was asking the question.
Sir, I think my question may be very basic, but
yeah, you can.
I just want you to go a little up at the beginning, sir.
This one?
Yeah. I mean, not this, the one where we wrote the code instead of using PyTorch.
Okay, yeah.
First of all, see what does images and label do? Images is it's going to extract the images in that input which you gave, and labels are going to be like if the digit is 1, then you will have the label as 1. Is it so?
Yes. So images is what I showed you. It's a 28 cross 28. It's a grayscale image. For 0, 0 will be written and the label will be 0. So likewise for in image.
I'm sorry, sir.
Yes.
So in the picture which you showed, okay, there are actually 100, I should say 100 symbols are there, right? 0 to 10, 10 times. I mean 0 to 9.
This one?
Yeah.
Yeah.
So, I mean, my understanding is when I say images dot shape of 0, am I going to get the first element in 0 which is there in this image?
No. So basically, what will happen is you need to understand how the images will be stored here. Okay. So when you write image 0, then you will get 0th image. If you write image 1, so you will be getting the first image. So likewise, in this example, I think there are 60,000 images. I'm not sure with the number, but there are some 60,000 images which are there in MNIST data set. And we will be using some for training and some for testing. And that is how, so as I showed you.
When I say images dot shape of 0, which image will I be getting? Will it be the first 0 which is there?
Okay.
I'm sorry if I'm
Yeah. I'll show you. So this one. So first thing is this is your train set. So train set will load the MNIST data set. Okay, and this train loader is something which has which is making sure that you fetch the data in terms of a batch size. So batch size of 64. Okay. So batch size of 64, as I told you that we will be taking the data from CPU from your hard disk CPU to GPU, and then that is what we fetch the data in a batches of 64. This batch size can be 128, can be 256. It all depends on what your GPU can handle. Okay. Then the question which you have asked is, so if I go over the train loader and if I iterate over the train loader, so data iter, so it will give you a data iter, and this will give me what is the next batch which I'll be fetching. So this is the next batch. So this will give me a batch of 64. Okay, so this is a batch of 64. This one is for a grayscale image. So you have a color image and you have a grayscale image. In a color image, you will be having a 3-channel because you have R, G, and B.
Yeah.
And then you have a grayscale, you have only 1 channel. So this is what 1 is for the grayscale, and this is your height, and this is your width. Okay, so if you write, this is where if you write image dot shape, so this will give you torch dot size 64, 1, 28, 28. So this is a batch of 64. 1 is for the grayscale, and 28 is your image, and 28 is your 28 is your height, and 28 is your width. Okay.
Okay, sir, this is what I'm actually trying to understand. That is, it would have fetched 64 images, each of size 28 by 28. Is that my question? I mean, my question is, 28 by 28 pixels are used to represent that one image 0.
Yes, 28 by
So,
28.
fetching 64 such images when you say batch size 64.
Yes, fetching such images. That such images will be containing can be containing 0, can be containing 1, can be containing 2, can be containing 9.
Okay.
So that is what shuffle will give you.
We will not know which one it is. This batch, anything.
We will not be knowing anything about which data is coming. The only thing is that we will be knowing the labels. So the corresponding label will also be fetched, and we will be pushing it to the model.
So that means we can say that we are inputting the digits image one by one. Is it like that?
So you can there is a good experiment which is available. For example, if you give one image to a model, and if you give images in a batches, so it is just like for example, in your school, if a student is appearing a board exam, okay, and for appearing a board exam, he has to write certain number of exams, okay, and every day, suppose if a student can write 365 days, if he writes exam, okay, and if there are 365 datas in your data set. So what is happening is, so I'll just compare it with the student. So student is writing 365 days exam, and in the 366 the day he has to appear the board. So every day he is writing the exam, you are correcting his question paper, and you're telling that you are doing mistake here. So he will be rectifying it. So he has got 365 attempts before he writes the board exam. Okay, and in this case, batches. So batches is nothing but you are updating your weights in a batch. So that means the frequency at which you're updating the weights will be less if you update image wise your model, and if you update your if your weights based on the batches. So did I answer your question?
Yeah,
Did
yes,
you
sir.
did you understand? Means if a student is writing exam every day, so the chances of him or her improving and coming up with good marks on the board exam, on the day of the board exam, is very high, just because every day you are giving him or her feedback. And if he writes exam for example monthly or quarterly, so there will be only 4 exams, and there will be only 4 attempts which he can make, and that is what on the day of board exam he has to perform. So
Okay.
if you update based on your images, so what will happen is you are there is some matrix operations which are involved in updating the weights, and this will take more time, and because of which you will be spending a lot of resources in updating the weights. The same way, if you take the example of a student, if you take 365 days exam, so sorry, there is a noise. Okay, sorry for the noise. What I was telling is, if you take 365 days exam, so what you are doing is you are wasting the resources of the school. So all the school resources will be used only for the exam purpose, and there will be no learning, all these things, no classes, everything. So the same thing is here. If you update your model weights for each and every image, so it will take more time, just because every time you are updating, so there is some, every time some tensor operation is happening. And but if you update your model weights in batches, so what will happen is you are trying to minimize the resources, and the time it will take will be less. Okay.
Yeah.
Sir, can you just scroll down a bit, sir?
Okay. This
Okay,
one?
so we are considering this particular image, which has come as part of our batch.
No. So in this one, so what they have
So
done
the
is
images of one actually has 3. Right?
This is they have taken the first one from images. So there are 64 images. So they have taken the first one, and the first one looks like this.
Okay, just a bit more scroll down. Yes, sir. So when I say images dot shape of 0, I am trying to change that 28 by 28 matrix into a single column matrix.
Yes,
right?
single column matrix of 784. So 28 cross 28 will give you 784.
Yeah. So we are correspondingly generating a 28 by 28 random weight.
Yeah, in this case, we start with the random weights. So this is a 784 cross 256, just because our input is 784.
That 256, I'm not able to follow, sir.
So 256, so I'll show you here. So this is a 784, okay? So this is your 784, and this is your 256. And then you have the output, you have a softmax.
Okay.
Okay, so in this case, this one is a input layer, you have a hidden layer, then you have hidden layer 2, and then you have a output layer where you have applied a softmax. So this is one more
Okay, so
neural
we are
net.
going to have a hidden layer which has 256 nodes.
Yeah, 256 neurons.
Yeah, okay.
From
Neurons.
784, we are going to 256.
Okay,
So
yes,
that is what has been done here.
Okay. Sir.
Okay.
Yeah.
So from 784, we are going to 256, and from 256, we are going to 10, just because it's a 10 class classification problem, and
We're going to have only one hidden layer, which is going to be 256, and then directly into an output layer.
Yeah, so this is what the output will look like. So output is nothing but your 256 and then 10. Okay, so 10 is your output, and then the output of the 10, you're applying a softmax. As I said, if you want to keep your probabilities between 0 to 1, so just you need to come up with a probability score from 0 to 9. So for that, you need to apply a softmax. So this is
So
what.
this sigmoid function will give me the sort of probability of each of those, and then finally one will be selected using the softmax. Is that right?
Okay. So maybe I think this part has not been covered. So maybe I'll ask this question. Why do we apply non-linearity? Why do we apply non-linearity? Can anyone answer this question? Why do we apply non-linearity?
Yes, sir. Maybe it is because we want to randomize the problem just one.
Not for
we want to
randomize.
randomize the problem so that the training could be done in a much better way.
No, nothing to do with randomization. But the usage of nonlinear function, as I said, ReLU is now being used. In fact, there is one more version of ReLU, which is leaky ReLU, which is being used just to overcome the problem of vanishing gradient. So what happens is when we train for 1,000 layers or more than 100 layers or more than 20, so I'll just show you one cool example. Yeah. So is my PowerPoint visible to you?
Yes, sir.
Okay. So if you see in the year 2010, and mm, we are going towards 2017. Okay, in the year 2010, it was a shallow network which won the ImageNet competition. Okay, so ImageNet competition, as I spoke about in this session, when I said that 2012 was the year when AlexNet was introduced to the world, and that is when they won the ImageNet classification. Okay, and this is a classification error. So if you see, the classification error at that time was 15%, and the number of layers is 8. And 2010 and 2011 is your shallow network. So basically, what they were doing is they were using handwritten, means they were using a feature based, so hand engineered feature based, and the output they were using a support vector machine, which was basically doing a classification. So this is what they were doing in 2010 and 11. So nothing much. So from 30% they were able to reduce to 25% in 2011. But if you see, 2012 is the year when they introduced deep learning, AlexNet, with 8 layers, and they were able to reduce the classification error to 15%. Okay, and if you see subsequently what has happened in the year 2017, the error was reduced to 2%, and if you see the number of layers jumped to 200 when you try to train this big layers, 200 layers. So you are trying to backpropagate from your error, you're trying to backpropagate to 200 layers. So that is where the vanishing gradient problem happens, and this problem is very much solved, is very much, means we were able to train this big layers of network. It is because of the ReLU. Okay, so ReLU is one which is quite popular. That is what I wanted to say when I am showing this. And if you see here, 2017 was the year when they stopped ImageNet competition, just because they felt that 2% is a remarkable result. And if you see the human accuracy, that it's a 1,000 classification problem, and human accuracy cannot surpass 2%, and that is when they stopped the ImageNet competition. Okay, so let me come to this one. So why do we use a nonlinear activation function? So first thing is, if you go by the universal approximation theorem, as one madam asked about how many hidden layers we should apply in a neural network. So as I said, it all depends on what kind of problem you are trying to solve. If you're trying to solve a simpler problem, then you need to add few layers. If you're trying to add complex problem, then you need to add more number of layers. And in this case, they have added 200. So, but this is an example of CNN, which I'll be covering in tomorrow's session. In this case, what is happening is, if you do not add some kind of nonlinearity, so that means you are not learning, means your hidden layers are not learning anything. You're not learning anything. It means if you do not add some nonlinearity, so this is a linear, means basically you are multiplying weight with the input and then adding a bias. So what is happening? So you're not learning something. So if you remove the nonlinearity from your input layer, from your hidden layers and output layers, what will happen is you're not learning anything. So that means basically if you add 10 layers, so it will be just like you have added only one layer. So that is the idea. So if you want to add 10 layers, then that means you need to add more of non-linearity. And if you do not add non-linearity, so your 10 layer neural net will look like a single layer neural net. So it is not learning anything. Even if you add 10 layer, so 10 layer will do the job of a one layer neural net. Okay.
Yes, sir.
Okay, sir.
Okay, so then what we can do is we can write this if you want to write in our example. This is a MNIST example, and this is a input layer. So we need to make it, as I said, we need to make it. We need to stack them up. We need to make it reshape 28 cross 28. So that will be 784. 784 is being converted to 128, 64. And then finally, you need to have a softmax. So let's see. You have nn dot linear. So you have 784, 128, then 128 to 64, then 64 to 10. And that is how you apply. So, okay, so this is FC1. FC1 will call here 784 to 128. And then you apply a ReLU. As I said, ReLU is the most popular non-linear activation function. And then you again apply a FC2 where you will be doing this 128 to 64. Then you apply a ReLU, then you FC3, then you apply so at the end they are not applying a ReLU. In fact, you need to apply a softmax. Okay, and that is what. And if you want to see the network will look like this. And if you want to see what are the weights, you can have a look. Model.weights. Okay. And yeah, so, and if you want to do a forward pass, this is a data iter, means this is a data iteration. You call the train loader, and the train loader will give you data of 64, and then you have one for the channel, and the 784 is your data, and then you need to reshape it. Okay, and if you want to visualize it, that's how it will look like. Okay. And if you want to train it, so this is where it has not given you anything. If you train it for more and more epochs, so that is when you will be seeing that the output will be more towards the layers. Okay, so that we will be seeing in our next Jupyter notebook. So before I do that, it's 3:30. Professor Bunil, are you there? Do I need to stop here, or I can go till 4?
So will you please share these codes with us?
Yes, I can share this.
I think the recordings will also be shared, no?
Yes.
Yeah, okay.
Okay. Okay, so I think you all were asking for some time for question answers. So do I need to stop here, or shall I go till 4? That's what my question is to Professor. Professor Bunil, maybe I think you are the best person to answer this.
Excuse me, sir.
Yeah.
Am I audible?
Yes, yes.
Sir, can we have a little bit discussion on basics of neural network? Actually, it wasn't covered. I don't think it's covered in this course. So if you like.
Actually, I have only half an hour time, and in this half an hour time, I want to go over more on neural networks. So.
Sir, I think actually tomorrow there is a session on introduction to neural
Sir, actually, we don't have, I mean, I don't know about others, but basically, we don't have any knowledge about these neural network and deep learning before your session. I mean, we have never done this.
Yeah, I think tomorrow morning there is a foundation of, fundamentals of neural network session.
So like we are zero in this. We are zero in this, and we are just beginners. So can you tell us the basic steps, like in sequence manner? Like first step is to load the data, and second, for example, in machine learning, what we do first, we just identify the problem. Second, we collect the data. Third, we cleansing the data. Fourth, we analyze the data, and then we apply some, or we train our data sets, or we train our models, and then we evaluate. So like we have a idea that the first step is to do this and second step is to do this. So in case of deep learning and neural network, can you tell us the basic steps or sequence, what is to be followed?
Okay. Okay, so first thing what you have to do is you need to first you need to have a problem statement first. What you want to do. If you want to do a image class classification problem, then you have uh, you have a 10 class classification problem, or 20 class, 100 class, or it's a 2 class classification problem. It's a then it's a binary classification comes up. That once you are done with that, then you need to come up with you need to choose a architecture. Okay, the architecture. So nobody uses neural net for image class classification problem. So basically, this neural networks are meant for your regression problems. But they are not being used for image classification problem. So for image classification problem, you need to come up with which model will be suitable for you. Okay, and that we'll be seeing in tomorrow's session. And you can what you can do is what the best way is to go over all the architectures which are available to you. So if I show you this one, these are some of the pre-trained image net models which are available, and this is the size. Okay, this is the size of VGG16, this is the size of VGG19, and if you see the size of VGG16 is 528 MB. So 528 MB. So as I said, so when you load the model into your GPU, so you are also loading the model. So that is the size of the model. So this many number of parameters. So this many number of parameters which will take this much shape, and there are 23 layers, and this is what the accuracy will look like. So top 5 accuracy is 90%, but top one is something in ImageNet. You have a 1,000 class classification problem. So if you classify first, means if you classified correctly, then that is a top one accuracy. But if your answer lies between top 5, even that is also considered as correct. So that is where it's 90%. Okay, and these are different architectures which were published over the years. So ResNet 50, ResNet 101, ResNet 152, then ResNet. Then this is the Inception from Google, then Inception ResNet V2, MobileNet V2. So it all depends. So what kind of problem you are trying to solve. So this is the ResNet, which is the most common architecture and cited in research paper for high accuracy. And if you want to do some MobileNet if you want to do it in mobile, then MobileNet is for the good balance between speed, size, and accuracy.
Sir, we would like to have some reference websites from where we can learn all the basics of this neural networks and deep learning.
Sir, one more thing, one question only. Sir, if suppose in my problem statement, or I want to make a model of that type which can recognize the image of a dog. I mean, I'm inputting the images of dog, and it can recognize that this is this type of dog, or this is the. So, what are the steps that we should follow from where we are taking the? Should we label them, or how we are going to solve that problem?
Okay, so cat. So there is an example. There is an application where there is one cat versus dog problem. So the data set is available to you. You can download the data set cat versus dog problem, and in ImageNet also there is a competition for different breeds of cat and different breeds of dog. So there is a classification problem, cat versus dog, and you don't need to label it. You will be getting the cat images with you. You will be getting the dog images with you. So what you have to do is you have to clean the data. Clean the data means the images may be of different sizes, different resolution. So that needs to be made to one single size or single resolution, and if you want to do some data augmentation, then that you can do to your model, and then you can choose any network architecture, and then you can do your cat versus dog classification problem. So this is a binary class classification problem, and this one is a 1000 class classification problem. That means you will be chopping off the last layer. I'll be showing you. So this is basically a 1000 class classification problem. Okay, this is where the ImageNet competition is. So instead of if you want to do cat versus dog, then you need to chop off this 1000 class, and you will be replacing it with two layer, and that is what you have to do, and then you have to train. So what generally what people do is they generally freeze these. They generally freeze this network, and they just train only the last layer. Okay, and that is what is being done. And if you see here, this is a CNN. So this is a CNN, and in CNN you have different layers. So basically, these layers will try to extract the feature, and this is where the fully connected layer or the dense connected layers, which I was talking about. So this is where it will be where you will be doing a classification problem. So if you want to do a 2-class classification problem for cat versus dog, then that needs to be replaced with a 2 neurons, and then you can train it. That's what.
Sir, I have a question here. So when I am trying to teach my grade 9 or grade 10 students about the same process that you are telling us right now about CNN and understanding about classification, I generically use the Google experiment called as teachable machine, right?
Which one?
So I use a concept of teachable machine wherein I give them 50 images of cats and 50 images of dogs plus a few set of images of myself. So that's a good example to explore if you want to teach. But my question here again is there any other example that we can make use of that where we can, something like a teachable machine kind of an example, where we can show the students in exactly how it is being done, other than just following the Keras, other than just following the TensorFlow object identification?
Okay, so there is one which has been launched recently. So I think it's a Lobe. Lobe, Microsoft Lobe. Maybe I think you can use that.
Yeah, I had heard about it.
Lobe or something. Yeah, this one.
Okay.
Maybe you can take this train apps to identify plants. So they have their own set of images, so you can use this. So you can use it for identifying different plants. Then they have different examples.
So just like you were showing us some code earlier using Tensor and Keras module, would it be possible for you to share that code with us so that we can play around with the content?
Yes, I'll be sharing it with you. So
Thank you
you
so
can,
much.
yeah. So you can train for crunch, rest. So this is a 2-class classification problem. This is a smile, laugh. So you can do emotional reaction. So there are lots of things what you can do. Hand gestures. So wildlife behavior, equipment. So there are lots of things which you can do with Microsoft Lobe.
Thank you very much, sir. This is quite helpful.
Okay, thank you. Okay, so anything else? Anything else? Would you like to ask question?
Sir, I have just one more question, if it's okay with you.
Yeah, you can.
So when we are teaching our grade 9 and 10 students, and we are trying to explain to them a little bit about the algorithms that they are using, right?
Okay.
So stats is something that basic stats, like, finding out the mean, median, mode, and, understanding about the graphs and all, they understand that part. but how to minimize the understanding quotient when I'm trying to make a grade 9 student understand about the logic and algorithm that is behind neural networks. So since this is a part of the CBSE curriculum, so it does become a challenge for us, because explaining to them about classification and regression, if it's a grade 11th or 12th student, it's still understandable. They have had a flair of economics and stats by the time they reach grade 11th and 12th. But how to minimize it's actually a challenge for me when I'm teaching about specifically about this particular chapter.
Excuse me, ma'am. Hello.
Yeah, I'm hearing you.
In that case, for teaching 9 and 10 student, I think we can play around with graphs a little, and there the maximum we can start with sinusoidal graphs, and explain them the minima is that where we try to reach. I mean,
Okay.
Explain how to minimize the error in the problem and how to.
And there is one more.
I think that would help a little bit.
Have you heard of this TensorFlow playground?
No, sir.
Okay, so maybe you can just have a look at the TensorFlow playground. So you can show this to your students. So basically you can add more number of hidden layers. So you will see.
Interesting.
So this is the data. So this is a circle. Then you can choose any data. And then it's a Gaussian, and then this is a spiral, and then you can play with the number of hidden layers. Okay.
Okay.
And then you can have a look how it works. Okay.
Okay. Thank you so
And
much, sir.
This one.
So can you share the link in the chat box if you don't mind?
Okay, maybe these two are cool examples. You can type in TensorFlow playground, and this will tell you. Okay, and anything else?
I just got it. Go to emojis. So can we reach out to you in case of a problem?
Actually, I'm quite busy, so it's finding
No
my
problem,
time
sir.
will
Thank you so
be
much.
very difficult. But yeah, in fact, you can reach to Professor Bunil or to.
Thank you so much, sir.
I think they can help you. Yeah. Anything else? If I can answer your
Another
queries.
one is the another one which you were showing is lobe. Can you show that again?
Yeah.
Okay. Yeah. Thank you, sir.
So even I have not tried this lobe, but I think recently, I think 1 week back, it was launched to everyone. So they have launched lobe from Microsoft for AI training. All these things you can do. So that's what they have done. Anything else? Any questions? If you have, just because what I felt is, if I go over too many concepts, but if you have doubt in your mind, maybe I think for tomorrow's session I should go much more detail. So I feel that. I should try to connect with your syllabus. What is there in your CBSE syllabus? But
Yes,
it's
sir.
very difficult to go over the syllabus and then try to come up with slides and presentation and then the codes. But I will try definitely. I'll try my best to come up something which I can answer to all your queries. Yes.
Yes, sir. So can you please suggest some resources where we can study this neural network?
Okay, so there is one good book, Neural Networks and Deep Learning. Maybe I'll tomorrow I'll share with you the good books and yeah, Neural Networks and Deep Learning. There is one good book, and the PDF is also available. Yeah, this one. Yeah, this one, if you want to understand neural networks and deep learning, so this is the basic one. And if you want to understand them, so this is the best. And they have this PDF also available. So maybe you can have a look at this one, neural networks and deep learning. And there is one more good book from deep learning by Ian Goodfellow. But that will be too complicated for class 9, 10, 11, 12 people. But anyway, you all people can read that deep learning Ian Goodfellow. Yeah, this one. This is the one. Yeah, this is the one. Deep Learning by Ian Goodfellow, Yoshua Bengio, and Arvind Corbili. So this is the book. Maybe you can have a look. I'll just share it with you. Anything else? But this book is really tough to understand if you do not come from any background from AI, so it will be difficult for you. But yeah.
Yeah,
But this
sir,
is
it was an enriching session, and I think we were really blessed that you are here.
Okay, yeah, maybe I think I should have. I had some 4 to 5 examples, but you all had so many questions, so I felt that I should answer all your questions rather than going over too many examples. And if I don't clear all your doubts, so that will not make any sense. That's the reason why I stopped. I think I just covered only 2 examples, and we went over more of questions and answers. So basically tomorrow what I will do is I'll just cover 1 or 2 examples from neural network, and then I will do to cover up the CNN part. Okay, and then I'll show you some more cool examples what you can do with the deep learning as well. Yeah.
As a suggestion for tomorrow's session, like
Yeah.
since some of the schools did not even start the artificial intelligence, some of the schools are they are already following the CBSE curriculum. So for those teachers, probably the term whenever we use the tense, everything when we use, maybe it will be very new for them.
Okay.
So to make sure that why we use that command or why we are using it and the purpose of it, probably we can start off with that explanation, and then going ahead with the program explanation will be a better way of understanding for the beginners, those who did not even start the
Okay,
artificial
I got it.
intelligence.
Okay,
Yeah.
so what I felt is even if you don't come up from that background, what I felt is if you come up with the terms, so maybe you can do some Google search. So all these are available, but I will definitely make sure that in tomorrow's session I should cover all the basic fundamentals. Okay, so yeah.
Just a recap session, kind of
Yeah.
just the terminologies and their use. You just have an idea of it. So when
Yeah,
you
I thought.
find the program, you will have a better idea.
Yeah, I thought some part of neural network is covered to you, and then that's the reason why I started with this one. Neural network. I started with writing neural networks in PyTorch. I was not knowing about that. Neural network has not been taught to you.
Okay. Great. Thanks.
Okay, I think if you do not have any questions, then I think we can end this meeting.
Yeah, thank you very much, sir.
Thank you. Bye-bye. Have a nice day.
Hello, Bunil sir. Bunil sir, are you here?
Hello. Yes, ma'am.
Bunil sir, I really wanted to know if you could share the document that sir was sharing with us today.
Okay.
It would be great if we can go through it today so that we can be a little bit more prepared for tomorrow's session.
Okay, he will share it today, by today only.
Thank you so much.
Thank you.